Polygons come in all shapes and sizes, and there can appear to be no connection between them, but geometry teaches us that there are rules which we can use to solve problems with polygons and to understand them. We're going to look at some of those rules in this short presentation. In particular, we're going to look at the simplest polygon and start with the triangle. Now we're going to begin our study of polygons by looking at the angles inside a triangle, the interior angles of the triangle. On the screen there you'll see I've got a triangle drawn. Let's measure the angles in that triangle. 100 degrees at the apex and 40 degrees for the other two angles. Now if we add those together, it gives a total of 180 degrees. And it turns out that in a triangle the interior angles always add up to 180 degrees. Let's move that apex to change the triangle, and you'll see if it works. There we go. Now the top angle is 95 degrees and the other two angles are 43 and 42, but they still add up to 180 degrees. Let's move that one again. Now we have 81 and 50 and 49. So it seems that it is in fact true. The interior angles always add up to 180 degrees, and no matter how we move this triangle and change it, we will always get a total of 180 degrees for the triangle. Now we've just learned that the sum of the internal angles on any triangle is always 180 degrees. But how are we going to prove that geometrically? Well, let's see. We begin by drawing two parallel lines. And within those two parallel lines, I will just build a little triangle. Thus. Now let's look at the angles here. We have two parallel lines and transverse lines crossing those. Now we know from our work in geometry that the angle at the bottom there is equal to the angle up there. And we also know that the other angle at the base is going to be equal to that angle at the top. And if we add in the apex angle, we'll see that that angle, which equals that one, that angle, which equals that one, and the apex angle always add up to form a straight line, or 180 degrees. Let's see what happens if we move this around a little bit. We'll move it down and up, and we'll see that no matter how we change this triangle, we will always have our 180 degrees. And so we've geometrically proven that the sum of the internal angles of a triangle add up to 180 degrees. So we've learned that the sum of the internal angles on a triangle is 180 degrees. Perhaps we can use that to work out the sum of the internal angles of any polygon. On the screen here I've got a hexagon, not a terribly regular one, but that doesn't matter. Now we'll begin by putting a point near the centre of that hexagon and then connect that point to the 6 corners of hexagon to create triangles like this. So we have 6 triangles. Now we know that the sum of the internal angles on those 6 triangles are 180 degrees. So the total of all the angles inside all those 6 triangles is going to be 6 lots of 180 degrees, or 1080 degrees. Then if we subtract out the 360 degrees around the centre, what we'll be left with is the internal angles of our hexagon. So we know now that the total of all the 6 triangles is 6 times 180, or 1080 degrees. Subtract out the 360 degrees around the centre, and we find that the sum of the internal angles on any hexagon is 720 degrees. Perhaps we can use this method to develop a rule for working out the sum of the internal angles of any polygon.